Good evening to all. In this video, we will discuss full functional dependency. Full functional dependency is opposite to the partial functional dependency. We will discuss now. See, what the full functional dependency will tell us. A functional dependency y arrow z where removal of any attribute from y means the functional dependent doesn't hold anymore. What it means? For example, just like similar case, partial functional dependency AB arrow C. Similarly, in the case of y, you have more than one attribute. Whenever any functional dependency holds like this, removal of one attribute, suppose I am removing A, the removal of one attribute is what it means? That means B arrow C. If it holds, then it is suffering with partial functional dependency. Then what the full functional dependency will say? Whenever there is a situation like AB arrow C, then A arrow C doesn't hold, B arrow C doesn't hold. Then this is nothing but full functional dependency, opposite to partial functional dependency. That means whenever there are two attributes at the left side arrow C, that means we have to allow that functional dependency part of the attribute arrow, that particular C, you are not supposed to accept. That is the meaning of this particular full functional dependency. Okay, removal of any attribute from y means the functional dependent does not hold. Okay, I think you got the clarity between partial functional dependence and full functional dependency. We can write another way of writing the partial functional dependency. Am I right? AB arrow C. Here you wrote only one. Am I right? So here you can write removing B means what happens? A arrow C. This is also called as, if this holds, this holds, this is also called as partial functional dependency. That means the part of the attribute not supposed to hold the functional dependency. Then only you can call it as a full functional dependency. That means 1NF to 2NF. If you want to convert, okay, if you have any partial functional dependency, you have to remove. That means you have to maintain the full functional dependency. That is opposite to partial functional dependency. Removing partial functional dependency is nothing but you are maintaining full functional dependency. See the example. This example is suitable for this particular case, full functional dependency. Okay, so AB arrow C. First we will check AB arrow C works or not. Okay, AB arrow C. Suppose A1 B1, A1 B2, A2 B1, A2 B2. See, A1 B1, A1 B2, A2 B1, A2 B2. For that, we'll see the right side values. Okay, suppose see, A1 B1 means C2, A1 B2 means C2, A2 B1 means C1, A2 B2 means C2. You have unique values for each left side value, so it holds functional dependency. Then we will check about B arrow C. For B1, tell me how many values are there? For B1 C2, B1 C1. That means C2 C1. Similarly, for B2 you can check B2 C2, B2 C1. That means what happens? For each left side value you have two values, so it doesn't hold functional dependency. Then another one, A arrow C. A arrow C, tell me the values A1, C2. That means only one value C2. For A2, A2, C1. A2, C1. So this is C1. So it holds the functional dependency. See, in this table the values are wrong. Now I will change the values. Okay, let us consider these values so that it will satisfy the A arrow C. Okay, because what is our theme? Full functional dependency means whenever there is a situation like AB arrow C, it must B arrow C doesn't hold the functional dependency, A arrow C doesn't hold the functional dependency, B arrow C doesn't hold because you observe the values. Similarly, you will observe the values for A arrow C. For A1, tell me the values C2 C1, C2 C1. Similarly, for A2, tell me the values A2 C1, C2. So it doesn't hold the functional dependency. So this is the right example. You can take the values for CR C2, C1, C1, C2. This is correct. Okay. So in this example, AB arrow C holds the functional dependency, B arrow C doesn't hold the functional dependency, A arrow C doesn't hold the functional dependency. So it is satisfying the full functional dependency. Thank you one and all.